Dwell for a moment on the image of a knife slicing through the air, its gleaming blade whirling towards a second stationary knife. What happens when the two collide? Does the first knife shatter, or does it ricochet off the second blade? The answer may surprise you. This isn't a scene from a Hollywood blockbuster, but a real-life physics experiment. And the answer to this seemingly simple question is far from straightforward. It's a dance of forces, materials, and motion. When a knife is thrown onto another knife, the outcome is largely dependent on two factors: the material composition of the knives and the angle at which they collide. If the knives are made of soft metal, they might bend or warp upon impact. But if they're made of a harder material like steel, the result can be quite different. Imagine the thrown knife spinning through the air, its sharp edge aimed directly at the stationary knife. On impact, the knife doesn't shatter or break. Instead, it bounces off. This is due to the hardness of the steel and the principle of conservation of momentum. Conservation of momentum states that the total momentum of a system remains constant if no external forces act upon it. In simpler terms, the momentum of the thrown knife before the collision must equal the combined momentum of the two knives after the collision. The collision also generates a sound, a clear, ringing note. This is caused by the vibration of the blades, which is then transmitted through the air to our ears. The pitch of this sound can tell us a lot about the hardness and density of the materials involved. To summarize, when a knife is thrown onto another knife, the result is not shattering, but a ricochet caused by the conservation of momentum. The material of the knives plays a significant role in what happens upon impact, with harder materials like steel causing a bounce rather than a break. And the sound created during the collision provides insight into the properties of the materials involved. In the end, this seemingly simple experiment unveils a complex interplay of physics principles and material science. It's a vivid demonstration of how everyday objects can serve as a stage for some of the most fundamental laws of nature.